I am Mike Oderera, project team Mike Wins, project title Designing a Telematics System for Road Freight Transport. Over the last few years, cargo volume has drastically increased, resulting in the number of demand of freight transport capacity to serve our country. On the other hand, the National Railway of Zimbabwe and their machinery are malfunctioning and inefficient, which has resulted in the modal shift and a rapid increase into road transport. Because of the enormous growth in cargo volume, which has increased into demand for road freight capacity to serve our country, it is necessary to improve operational efficiency. Only with the expansion of infrastructure such as roads and vehicle does not seem to be a sustainable plan. The increase leads to other negatives both to the society like accident, carbon emission, constraining government budgets by funding transport sector for infrastructure rehabilitation like road construction, resurfacing, customers like customer order delay, in logistic company by reducing zero mileage, fuel costs a major challenge in Zimbabwe and loss of assets. The innovators' aim is to design a system that benefits the customer, government agents, our company, society, telematics system provider, and road users. In brief, the researcher needs to come up with a proper solution to move Zimbabwean freight transport efficient, e.g., for example, digitalizing the road freight transport sector. Our telematics system aim is to minimize transportation time delay, to improve infrastructure utilization, to minimize fuel consumption, to improve safety to both user and customer goods, to reduce traffic congestion, to remove truck brokers between industry and our company. System overview. The proposed multiple service architecture telematics system of rail freight transport is assumed to be an open system with several functionality that can potentially host multiple coexisting transport telematics system which vary from a degree of restriction, which shows by the figure below. Shows all possibility service integrated to build a multi-service architecture, which the figure below shows all possible service integrated to build a multi-service architecture system with the interoperability service and functionality. The picture shows a section with users at the top. The users are drivers, freight manager, customer, VID, transport service provider, dispatcher, and Zinara. The proposed multiple service architecture of the road freight transport is now divided into three sections shown by the picture. But for better understanding, let me explain below at the application level at the bottom. The fleet logistic optimizer is already designed and can be accessed at the link below. There is a documentation of a already developed system for fleet logistic optimizer, which is in red indicated by the picture. So you just click to the below link and see the documentation and even to ask for a demo execution program that demonstrates how the fleet optimizer works. The multiple service architecture of this telematics system is divided into a number of components, which is illustrated by the picture. The fleet logistic optimizer can be shown on the link below how it works. And then we go to the GPS, the driver monitoring, the web booking posting, and the Zinara payments. All those systems is now being integrated to show a one system that works together to solve those irregularities on the road. So the aspect of this system is divided into three components. We have a system, a GPS system on the board of the truck. Then we have a web booking, those who installed in the departures or those with the loads. Then last, we have an application used by the manager to check the device, to check the loads, and to see the driver's movement.